Just leave it there for a second. Chebyshev was a Russian mathematician who studied data. And Chebyshev's theorem, I'll put them both over here. Says that if you let K equal a whole number greater than 1, where K is the number of standard deviations away from the mean, then he can tell you how much data you will bound. So for our data, for example, if we let K equal 2, which would be 1 standard deviation, 2 standard deviations, to the left or the right, if K equals 2, Chebyshev says that you will have bounded at least 1 minus 1 over K squared of the data. So that's a lot of words, okay, so let's see what it means in our case. So we're going to K equal 2. K is the number of standard deviations. I'm going to go from the left to from the left and from the right of the mean. So if I go 2 standard deviations, okay, K equals 2, he's saying that I should have at least 1 minus 1 over K squared of the data. Well, what's 1 minus 1 over K squared if K is 2? 1. Well, there's the 1. I'm subtracting something off the 1. 3/4. 3/4. 1 minus 1 over K squared. What's K is 2, so that's 2 squared, that'd be 4, right? So that would be 1 minus 1/4. So he's saying 3/4 of the data, or to be bounded between 2 to the left and 2 to the right. So if I go 2 to the left, I would do 81.9 minus what? Minus 2 times this. So what's this number? That number is going to be 81.9 minus 2 times 9.23. This up here is going to be 81.9 plus 2 times 9.23. What are those two bounds? What's the left bound and what's the right bound? What's this number? That's going to be 2, this minus about 19 or 18 and a half. This is plus about 18 and a half. Well, so what are those two numbers?
63.44.
What's the first one, Joey?
63.44.
63.44. Anybody else get something like that? You get that, Andrew? What's the upper bound? 100.36. What is it, Mylan? Milan?
Yeah, it's 100.36.
100.36. 100.36. Does that look right, guys? So what Mr. Chebyshev says in his theorem is that between here and here, or between 63.44 and 100.76, we ought to be able to find 3/4 of all of our data. Now, I don't remember, I know the lowest number we have is 61, right? So 61's not in that range, so that doesn't fit. And the highest is 104, isn't it? Is there another number below 104? What's the next number below 104? What is it? 98. So 98 fits in here though, right? So the only two pieces of data that we have that don't fit in that interval are what? The 67 and the 104. So it certainly is at least three-quarters of our data. So it works because we've got 28 pieces of data out of 30 pieces of data. Now the kind of magic with the Chebyshev theorem is that it doesn't matter what your histogram looks like. It will work for any picture of data. Chebyshev's theorem says at least 1 minus k squared. So if it's 2 standard deviations, that's where I get the 75% or 3/4. If I go out 3 standard deviations, if I went out 1 more standard deviation to the left, 1 more to the right, I get almost 90% of the data, at least. And what's kind of magic about his theorem is that it doesn't matter what the original spread or distribution of the data looks like. It could look very nice, it could look almost uniform, it could look good, bad, or indifferent. It works for any any data. Questions on Chebyshev, what it means. And there's a nicer rule we also call the empirical rule. And the empirical rule kind of does